Hi, I am Apoorv Bapat, working with Altair Engineering Private Limited. In this video, I am going to cover basic theory related to 1D elements. My first topic on this is when to use 1D element. So 1D element are used when one of the dimension is very large in comparison to other two. As you can see in this tutorial, in this example, that the length of the shaft is around 1000 mm, and the other two dimensions, that is the cross sectional area, is 5 and 10 mm, which is very small as compared to its length. So in that case, when your one dimension is very large as compared to other two, you can use 1D elements. Now the element shape which is used in 1D element is line. Additional parameters from the user which you have to input in the software for simulation of 1D element are the remaining two dimensions, that is its cross-sectional area. Element type used in 1D elements are rod, beam, bar, pipe, axisymmetric shells, etc. And practical applications of 1D elements are long shafts, beam, pin joint, connection elements, etc. Then the second topic of discussion is types of 1D element. So there are different types of 1D element available in HyperWorks. We will discuss them one by one. So first type available in HyperWorks of 1D element is rod element. Rod element supports tension, compression, loading. That means it supports translation along any particular axis, and in some software it also supports the torque, that is twisting movement. Then its practical application is tension compression members like truss and shaft subjected to torque, connection of elements. So these are the some practical applications of rod element. Then bar element. Bar element supports all the 6 degrees of freedom, that is it supports translation along XYZ axis and rotation along XYZ axis, and they are applicable only for symmetric cross sections. The practical application of bar element are shafts subjected to multi-axial loading, that is bolted, welded joints, and connection of elements in this they are also used. Then we go to the beam element. Beam element are same as bar, but they also support unsymmetric cross sections, that is shear centers and warpage they can support. Practical application of beam element is same as bar, but they also support these all the shafts subjected to multi-axial loading for unsymmetric cross sections also. Then there is one more type of 1D element available, that is pipe. Pipe is same as beam, but there is a slight difference in pipe element, that is it has an internal non-zero diameter. The practical application of pipe element is piping system structural analysis. Then there are one more type of axisymmetrical 1D element available, that is axisymmetrical shells. Axisymmetrical shell supports translation along x-axis, translation along z-axis, and rotation along y-axis. That is, if in z-axis of symmetry the axisymmetric shell is there, then in x it shows a radial axis. They are mostly used for the object symmetric about the axis of rotation and subjected to axisymmetric boundary conditions. The practical application of this axisymmetric shells are thin shell pressure vessels and cylindrical conical objects. So these are the basic introduction to the theory of 1D element. Thank you very much.